This is the second demo that accompanies the lesson on failover clustering fundamentals. In this demo, I'm going to show you how you can provision a SQL Server 2012 multi-subnet cluster, or commonly known as geographically dispersed clusters. This demo is based on an article that I wrote on mssqltips.com last year on how to work with SQL Server 2012 multi-subnet cluster. And while the article uses Windows Server 2008 for its underlying operating system, the concepts are the same. In the article, I've outlined the network diagram that I used for this particular environment. So I've got domain controllers, DNS servers that are getting replicated. Cluster nodes that I will use for the cluster are in different data centers, and I used iSCSI storage. Now, the storage will be anything as long as it does support block level replication and failover clustering. So this will be the basis of the demo that I'm going to do. Again, I strongly recommend that you go through the article to understand the concepts even better. This is no different from what I've done in the previous demo on building a SQL Server Failover Clustered instance. The only difference is that now I'm dealing with SQL Server nodes or cluster nodes that are in different geographical locations or in different network subnets. I've repurposed WS Cluster 3 and WS Cluster 4 for this specific demo. Nothing in here yet. I've provisioned cluster storage for WS Cluster 3 and WS Cluster 4 that are configured to do block level replication between data center number 1 and data center number 2. Now, to prove that point, notice that I have different IP addresses for these two. This is my IP address for WS Cluster 3, 172.16.0.213, and this is my IP address for WS Cluster 4. They are in two different network subnets. This will be the basis of creating a multi-subnet cluster. Just like before, I've already turned on the failover clustering feature on both servers. So the failover clustering feature is already turned on, again to save on time. And the storage have been attached to these two servers. Of course, the .NET Framework 3.5 is already installed because this is a prerequisite for SQL Server 2012. I already have Failover Cluster Manager, and I strongly recommend running the Failover Cluster Validation Wizard for this specific configuration, primarily because you want to make sure that the storage you're using is supported. Click on Next. And just like in the previous demo, I'm going to add both WS Cluster 3 and WS Cluster 4 in my cluster. Next, and I'll just walk through the entire process because you've already seen this in the previous demo. And I am going to run all of the tests. I want to make sure that my storage is configured because this highlights a very important concept. SQL Server relies on the underlying storage subsystem when you're dealing with failover clustered instances. A couple of things to consider. Number one, unlike a failover cluster where the nodes are in the same data center, both machines are connected to the same disk subsystem. In a multi-subnet or geographically dispersed cluster, the nodes that you will join in the Windows Server Failover cluster don't necessarily have to be connected to the same disk subsystem. I mean, come to think of it, if one node is in the United States and the other node is in Canada, there's really no way for them to be connected to the same disk subsystem. The approach is to make sure that your storage subsystem supports block level replication, which means a block of storage on one of your data center is getting replicated to the other data center. That fools the operating system to think that it's looking at the same disk subsystem. But in reality, the blocks are getting replicated from between the data centers. And that's what I'm using here. The reason I want to make sure that my failover cluster validation wizard succeeds is, based on my experience, a lot of storage are not properly configured, especially when dealing with multi-subnet clusters. And this is important. You wouldn't want to create the cluster if there are issues with the storage. And just like in a previous iteration of the failover cluster validation wizard in my standard failover cluster, this will take time depending on the number of nodes, the sizes of the storage that you want to use for this cluster, and in this case, since the servers are in two different network subnets, the traffic between network subnet number 1 and network subnet number 2. So my failover cluster validation wizard is complete. Let's take a look at the report to see what we have here. Looks like everything is doing well. Inventory, network storage, system configuration. Based on my experience, I almost always have issues with storage, depending on how it's configured. So I strongly recommend that you fine-tune your storage configuration to make sure that they support multi-subnet or geographically dispersed clusters. I'm going to close this, and I will create my cluster based on those two nodes. If you look closely, I now have two IP addresses. One for my production data center, which is the 172.16 subnet, and my DR data center, which is the 197.160 network subnet. This is how Windows now sees your cluster. You're working with nodes on different data centers, and it's providing you with an option to provide IP addresses for both network subnets. Keep in mind that if you will be dealing with cluster nodes on more than two network subnets, the number of virtual IP addresses will be the number of the network subnets. In this case, I only have two. If you would have three network subnets, you would have three virtual IP addresses. And because I'm not going to guess the values for this, I will go back to my cluster preparation checklist. When cluster 2, I'll use these two virtual IP addresses, 16.0.211 and 192.168.0.211. When cluster 2, I'll use 211. And I can ignore some of these. It's detecting some of the IP addresses that I have. Now I use the 197.160 subnet for my heartbeat, so I'm not going to use that. I'm only going to use 172.16 and 192.168. Next. Based on the virtual IP address that I provide, it will create the cluster, in this case the Windows Server Failover Cluster, with WinCluster2 as the name of my virtual server, and these two IP addresses. Going back to our lesson on failover clustering fundamentals, it will create its corresponding Active Directory object and the DNS entry. In this case, it's not just going to be one DNS entry, but rather two DNS entries. I'll click Next to create a cluster. And again, as I mentioned, this will go out to Active Directory, checks if this object is already there. If it is, it's going to throw an error. If it isn't, it will create the virtual computer object and its corresponding DNS entry with those two virtual IP addresses. This will form the foundation of where you would want your SQL Server instance to run on top of. Windows Server 2008 has supported running clusters that span geographical locations or multiple network subnets, but SQL Server 2012 was the first version of SQL Server that natively supports multiple network subnets. and this is why you've probably seen in the article that I was using Windows Server 2008 with SQL Server 2012. So the cluster is created. There were a couple of errors. Disk number 1 could not be brought online. I'm okay with that. Disk 1 and disk 5. Go ahead and finish. And the cluster is created. So now I have a Windows Server Failover cluster with storage. So 2 of the disks, I've got like 3 disks in there. Cluster disk 1, 2, 3, 4, and 5. If I look at cluster disk 1 and go back to my disk management, disk 1 is reserved. Well, this is supposed to be a local disk. This is where tempdb is supposed to be running. So I am going to exclude that. This is one thing about using geographically dispersed clusters with SQL Server. You can choose to store tempdb in the SAN drive or in the shared storage, but in this case, I wouldn't want to be replicating tempdb. So I will exclude this. Yes, I don't want this to be included in my cluster. And cluster disk 5, which in my case, I don't have cluster disk 5, so I'm good. Going back, I'm going to bring this disk online. And notice, this is actually a local drive. So let me just mark this drive as drive, say drive T for tempdb. Or let's just rescan this. It already has a drive E. Remember the demo that I did on the traditional failover cluster. This drive, if you intend to use local drives for tempdb, has to exist on the other cluster nodes, and the file format, which means the file structure, the folder structure, and the permissions have to be exactly the same. Refresh my disks. So this is a local drive. Disk 2, 3, and 4 are cluster drives. Disk 2, 3, and 4 are local drives. I can remove disk number 5. There we go. Disk 2 would be my data drive. So let me change the properties of this disk. Make it even more meaningful. I'll call it F data. Disk 1 is for my backups. So I'll call this H. My best practice has always been to rename cluster resources so as to not get confused when you're doing your cluster configuration or even managing your servers. So let's call this G log. And if you notice, I'm now starting to implement best practices in my storage configuration, where I have a dedicated drive for data, dedicated drive for log, of course, local drive for my tempdb, and dedicated drive for my backups. For my network, I've got a couple of network here, so I'll rename all of them. This is for my production network adapter on one of the networks, and this is for my DR. Same thing with this. I'll call this heartbeat. This one is for my production. And this one, I believe, is for my heartbeat. Notice you have this option to configure this particular network adapter if you want it to be dedicated for heartbeat communication. While I have a dedicated network for heartbeat, I still kept the production network adapters to allow heartbeat communication. In this case, I've got multiple network communications on my cluster via my production network adapter and my heartbeat network adapter. I've got no roles yet. My nodes are prepared for. I've got the disks configured. I've got my network adapters configured. I'm ready to go and install SQL Server on top of this multi-subnet Windows Server Failover cluster. It's going to move into my SQL Server Installation Center. And just like in the traditional way of installing a SQL Server Failover clustered instance, I'll spin off a new SQL Server Failover cluster installation. Verifying some of the rules. All the initial rules have passed. I won't include the SQL Server product updates because my Service Pack 1 is already a part of my media, something that I didn't do in the previous demo because I want to show you how patching works. In this case, my installation media already contains Service Pack 1. Besides, I don't have connectivity to the internet, so I'm going to skip past this. Running the second rule check. Again, I am prompted for the MSDTC clustered resource, which is not available. Again, I know that I'm not going to use clustered DTC for the SQL Server instance, so I'm okay with that warning. Microsoft .NET Application Security, Windows Firewall. I'm okay with those warnings, and I can go ahead. But again, just like what I mentioned in the previous demo, if you are going to use the MSDTC or the clustered MSDTC for your instance, make sure you configure that. I'm going to click Next. I'm using Evaluation Edition for this particular demo because I just don't want to show you my product key. Click Next. Accept the license terms. Click Next. Feature installation. And just like in the previous demo, I only need the database engine services for this particular installation. Don't want to be adding anything else. I only want the database engine for this particular cluster. What else? Documentation and management tools. Click on Next. Another rule check. Click Next. It asks me for the SQL Server network name. Again, this will be the virtual computer object that this instance will represent in your network. I'm not going to guess the network name, so I'll go back to my cluster preparation checklist, in this case SQL 2012 Clus 2, and I'll use the virtual IP address 172.16.0.217. I'm going to be using a default instance for this particular database instance that I'm installing. Click Next on the Disk Space Requirements dialog box. Similar to what we've done in the previous demo, it's still going to ask you for the SQL Server cluster resource group name. I'll keep it as it is. For the disk selection, I want to use G and H. I wonder why my F drive is not available. Because my F drive is used as my quorum drive. Now I want to pause for a minute here and give you some of the insights here. It made sense for a traditional cluster to use a quorum disk. That is because the disk is just in one data center. It wouldn't make sense for the cluster to have a quorum disk for quorum witness, because now you're dealing with two different nodes on different data centers, which means you have to replicate that disk on both data centers, so from production to DR. I'll get back to this window and configure my Windows Server Failover cluster. I'll click on my top level node. If I expand my cluster quorum resource, note that my F drive was used as my disk resource. Now I want to change this. As I mentioned, I don't want to be using an expensive clustered storage for my disk witness. This is where the file share witness option comes in very handy. So I'm going to change this similar to what we did before. More actions. Configure cluster quorum settings. I am going to change my cluster quorum settings to not use a clustered disk, but instead use a file share witness. I'll select the advanced quorum configuration and witness selection. Click next. I'll choose both nodes. I'll allow the cluster to dynamically manage the assignment of node votes. I will walk you through the process and explain further how this thing works when we go to the demo on geographically dispersed nodes that you will use for always-on availability groups. But in this case, I'll keep the defaults. I will select the second option, configure a file share witness. This adds a quorum vote of the file share witness. Now, the reason I'm doing this is, as I mentioned, you only need 1 gigabyte of quorum, or actually it's 512 megabytes for your quorum disk. Not an issue if both of your cluster nodes are in the same data center, but now you're spanning geographical locations in different data centers. I wouldn't want to be replicating 1 gigabyte or 512 megabytes of clustered disk storage between data centers. It's expensive. I'd rather save that clustered storage for something that's more important to me. And that's why I'm going to use the file share witness for this purpose. File share path. I'll use a file share path that's accessible to all of the nodes in my cluster. And I want to make sure that this file share is hosted on a highly available file share, maybe a clustered file share if you may. I'll click on next and next and configure. So now I've changed my cluster quorum setting from a quorum disk, the traditional quorum disk that we've used in the past, to a node and file share majority. Click finish. And this would change my quorum configuration to node and file share majority. Quick hit refresh here. For storage, I don't need the storage for this cluster since I already have my file share witness. So I'll take this drive offline. And in my disk, I'll bring this disk online because it's no longer being used as a file share witness. So I will move this disk to my available storage. So I right click on my drive and say remove from cluster group. This makes the cluster drive available to my SQL Server instance because I really want that F drive to be used by my SQL Server instance. So I switch back to my installation, click refresh, and that will take quite a while. In some cases, I have to restart my installation process for that particular drive to be available. So I had to restart my whole installation process for the changes to be taken effect. Click on yes. So now my data drive is now available in my failover cluster installation. I'm going to select all three. So these cluster drives will be dedicated for that particular cluster resource group. Be careful with this, because if you intend to use multiple cluster drives, you can't just remove them out of the clustered resource group, especially if you have system databases and user databases on those cluster drives. I'll click next. IP addresses. I already have provided the IP address for this. I want you to pay close attention to the list of IP addresses. In the traditional failover clustered installation that we did in the previous demo, you didn't see a lot of these options. You're only provided with one network adapter, and that will be used for this particular installation. In this case, I am only going to use my LAN DC1, and the reason that I'm getting 2 is because of my network adapter configuration. I want to fix that. So go back here. Heartbeat. I don't want to allow clients to connect to this network. I'll click on apply, because again, this is my heartbeat network. Same thing with the other heartbeat network. I don't want to allow clients to connect through this network. So I've only left my public network adapters, or my public network adapters, with that option to allow clients to connect to this network. You want to make sure that you fix this before moving on with the installation. Go back to the installation, refresh. Note that I'm now just provided 2 options. The first one being is my domain controller 1, or my data center 1 rather, and its corresponding network adapter. Next is my data center 2 with its corresponding network adapter. I can't modify this at this point because the node that I'm working on, WS Cluster 3, is in my primary data center, and that's the only network adapter I'm provided with. I'll use 172.16 for my virtual IP address for this instance. I'll click on next. The database engine and the agent service accounts are requested. And again, reminding you of the fact that when you go back to the previous demo that I did, the order of the database engine and the SQL Server agent service accounts are reversed when you're adding nodes. Be very careful, especially if you're using different service accounts for the agent and the database engine correspondingly. In my case, I'm only using the same service account so that I don't have to worry about this. Click next. In the database engine configuration dialog box, I want to make sure that I am allowed, and I'm adding myself in the sysadmins row in this particular instance, data directories. I now have different folders provided for me. The first thing that I need to do in this case is go back to my E drive. I want to make sure that this is online. My tempdb drive. So I want to go back to my E drive, create a folder, because I want to store my tempdb in my local drive. want to make sure that I grant permissions to my SQL Server service account. So I'll add my SQL Server service account and grant it full control permissions on this particular folder. It's the same thing that I will do in the other node when I initiate the installation process on that node. So for tempdb, I'm going to use the local drive, emsql. For my data directory, I'm going to be using the F drive, and I'll follow the structure that I had earlier. fmsql. My log drive will be G. And my backup drive will be H. I'm highlighting a couple of best practices here where you're provisioning physical drives for your data file, your log file, your tempdb database, and your backup files. Similar to what we encountered in the previous demo, you will be prompted with this message telling you that tempdb database is being stored on a local directory. We've already taken care of that. We have tempdb being stored in the local drive, and I want to make sure that when I add a node, WS cluster 4, to the SQL Server instance, I will have the drive letter and the folder and the path and the permissions the same way that I did with this particular node. Click on yes. Click next. Last rule check. Click next. And run the installation. As I mentioned, I've already used the SQL Server 2012 with Service Pack 1 installation media for this particular demo. So I don't have to patch my nodes in and install Service Pack 1. I may have to install cumulative updates or security patches. But again, going back to the previous demo, you start with the node that's not running the resource group, patch that, failover, and patch the other node. I'll pause the video and come back when this installation completes. So the installation is complete. Everything is looking good. So now I have a working SQL Server clustered instance, not highly available because I only have one node. Click close. If I go back to my cluster, I now have the MS SQL Server resource group. And in that resource group, I've got all my cluster drives, my virtual IP address, and my virtual server name. I'll click on the clustered resource group, and this will show me all of my resources in that group. Again, this is nothing different from the traditional SQL Server Failover clustered instance, where you have your virtual server name, virtual IP address. Right now, I only have one virtual IP address. When I add the other node, I will be presented with two virtual IP addresses. I got my storage, my SQL Server clustered resource, and SQL Server agent clustered resource. Again, you can look at the dependency report, or in this case, I want to look at the SQL Server dependency report as a reference. One thing you've seen in the previous demo on the traditional SQL Server Failover clustered instance is that everything uses the AND logic condition. The AND logic condition simply means that all of the resources have to be online before one resource that's dependent on them go online. When I add the other node, you would start seeing an OR logic condition, which means one or another resource can go online in order for this particular resource to go online. So I'm done with WS cluster 3. I'm going to WS cluster 4 and add this particular node. Go on installation. And again, similar to the previous demo, I'm going to add a node to a SQL Server Failover cluster. I'm just going to go through all of the pages because they're exactly the same pages that we've seen in the previous demo. What I would like to focus on for this particular adding of node is when you're presented with an extra page where it asks you for the virtual IP address of this particular network subnet. Click OK. And again, skipping past the page where it asks for my product key, accept the license terms. I'm not going to include SQL Server product updates because my nodes are not connected to the internet. And just for me not to get confused, I am connected to WS cluster 4. So I'm using my WS cluster 3 session to connect to WS cluster 4 because it's on a different network subnet. My main workstation does not have access to that particular network subnet. And running the setup support rules check. I still see the distributed transaction coordinator warning. I'll click next. Note in this case, it already sees the SQL Server instance name. It sees the cluster network name. That's already installed on this Windows Server Failover cluster. So we're just going to add this specific node. This was what I was mentioning about the cluster network configuration. In the traditional SQL Server Failover clustered instance where the nodes are in the same data center, in the same network subnet, you won't even see this page. But in this case, since this node that I'm adding, WS cluster 4, is on a different network subnet, it's asking me for a virtual IP address for the specific subnet. So I'm going to select IPv4, and I'll use 192.168.0.217 for this particular network subnet. Click next. And you will be prompted with this particular message. SQL Server detected that there are multiple subnets. Now, one major consideration when you're dealing with multiple subnets or a cluster that spans geographical locations or multiple subnets is making sure that your networking stack is well defined and well configured. So you want to talk to your network administrators on how this is properly configured. It also tells you the resource dependency using an OR relationship. And I'm going to show you that later when we go back to the Failover Cluster Manager and see the dependency report. I'll just click on yes. The SQL Server service account, as I was mentioning, the database engine comes first before the agent. So be very careful with that. I'm just going to provide passwords for my service account. Go to the error reporting page, click next. Final rule check before the node is added. Summary of all the changes for adding the specific node. And install. Again, this is going to take quite a while. So what I'll do is I'll switch back to WS Cluster 3 and show you some of the network properties that we need to tweak as far as the cluster resources are concerned. So you're seeing a PowerShell command that I'm going to use to take a look at the different cluster resources. I'll start with the get cluster resource. and I want to take a look at the different resources in my cluster. So this is a list of the different resources in my cluster. I've got my cluster IP, my IP address, cluster name, my IP address 2 for SQL. I don't have my other IP address for my cluster virtual IP address yet. It's going to come into the cluster once the node has been added successfully. But what I'm really concerned and what I want to pay attention to is this particular network name. In a multi-subnet or geographically dispersed clusters, since you're going to be dealing with 2 IP addresses, one for your production data center and one for your DR data center, you have to modify how your network would respond. In this case, the network name will be registered to my DNS. So I have to modify the properties of this specific network resource. I'm going to grab this command. I want to list all the cluster parameters for that specific network name resource. I'm going to paste that. Oops. And I want to make sure that I copy this. There we go. So I'm running the get cluster resource PowerShell commandlet, passing the name of my cluster resource. In this case, I'm interested with the SQL network name, which is SQL 2012 cluster 2. And I want to list all of the parameters for that specific cluster resource. A couple of things to focus on here. First off, register all providers IP. With SQL Server 2012, the default value is 1. What this parameter means is all the virtual IP addresses that I've configured for the SQL Failover cluster will be automatically registered in my DNS. Why is that a concern? Well, if this property is set to 0, the only time that the virtual IP address gets registered in the DNS is when that virtual IP address is brought online on that specific network subnet. Think of it this way. 172.16.0.217 is my virtual IP address for my production data center. My 192.168.0.217 virtual IP is not going to get registered on my DNS server until I fail over my entire cluster resource group, or even just the resource name, but again, the resource group is going to get failed over. That is going to affect how your clients or applications connect to the cluster resource name. I mean, think about it. The default DNS client cache is 20 minutes. If I don't register my virtual IP addresses or all of the virtual IP addresses in the DNS, my client might not have that DNS value with its corresponding virtual IP address in its cache. Again, the default is 1, so no need to modify that. The next property that I am concerned with is host record TTL. This is in seconds. So 60 seconds, 1 minute, 1200 seconds, 20 minutes. Why is this of concern? Again, imagine your client applications caching the DNS entries. If it takes 20 minutes for my client to flush the DNS cache and request DNS entries to my DNS server, that will affect my application failover time. It also means that even though my databases have failed over in less than a minute, my client applications still won't be able to connect to my databases, and that would affect your service level agreement and your recovery objective. That is really not a database issue. It's a DNS and networking issue. But since it's running on the cluster and SQL Server depends on that, your application may think that because it can't connect to the database server because of the DNS caching, it will think that the database is down. So we need to change this value to something that's relevant for this specific DNS entry or this network resource name. I'm going to change that value to something like 300 or 5 minutes. So I'm going to set the parameter value, and notice that I have a PowerShell script in here that changes the register all providers IP parameter value to 1, just in case I haven't had the value set to 1, but in this case I already have it set to 1. And I'm going to change the host record TTL value from 1200 to 300. So I'm going to copy this command and run it on my cluster. Now you can run this PowerShell commandlet on any of the nodes in your cluster. In my case, I just feel like running this on my WS cluster 3 node, since the other node is still finishing up the add node configuration for my SQL Server Failover Clustered instance. Paste that. So initially I have 1200. I'm going to change it to 300. Says the properties were stored, but not all changes will take effect until the network name is taken offline and then online again. We're going to do this as part of the failover test, where we will take the SQL Server resource offline, move it to WS Cluster 4. That will take the cluster network resource name offline and bring it back online. We can rerun same query or PowerShell script. Note that my host record TTL is now 300, which was changed from 1200. You might want to talk to your DNS administrators on this specific value. What this means is that all your applications will have to request DNS records from your DNS server every 5 minutes. If that's something that you think is very aggressive, again, talk to your DNS administrators about the right value for this without blowing up your recovery objectives and your service level agreements. Let's get back and check WS Cluster 4. It's still running. I'm going to pause the video and come back to this when the whole process completes, and then we'll do the failover and the failback test. So the add a failover cluster node process is complete. Everything's looking good here. Now that's done, let's go back to our failover cluster manager and do a failover test. But before we do the failover test, I want to focus on the virtual IP address. Note my clustered resource name or clustered network resource name. Initially, I only had one IP address in this list. Now I have 2 IP addresses. One for my 172.16 network subnet and one for my 192.168 network subnet. Note that only one virtual IP is online at any given point in time. You can't bring both virtual IP addresses online at the same time. Again, talking about how the DNS client works, if both IP addresses are stored in cache and the client requests for that specific IP address, if one of the IP address or if both of the IP addresses are online, the first one that responds gets to be the first one that my application connects to. Now, what if that particular virtual IP address does not have the resource in the resource group? My request would fail. And that's why the virtual IP address for the other network subnet is not going to be online. Only one virtual IP address will be online at any given point in time. And this is where I want to point out the OR logic condition, well, not the SQL Server clustered resource, but my network name resource. I want to show the dependency report for that. This is where the OR logic condition now appears. In the past, it was just the AND logic condition. See here it says the ampersand represents AND, and the whatever that symbol is represents OR. And what this graphic simply means is any of this IP address or this IP address, any of these two can be online before the network name goes online. That's the OR logic condition. Contrast that with AND, where both have to be online before my network name can go online. Let's take a look at the dependency report for SQL Server and see a combination of the AND and the OR logic condition. The SQL Server service or the SQL Server clustered resource still has the AND logic condition. Notice all the drives, drive G, F, and H, they all have to be online prior to SQL Server going online, which means if any of these four is not online, your SQL Server resource will not come online. Unlike the network name resource, I've explained earlier, any of these two virtual IP addresses can go online for the SQL Server network name resource to go online. This concept is very important when you're dealing with troubleshooting, failing over and failing back, and why one of the resource is not going online. The dependency report will give you that insight. And as I mentioned in a previous demo, copy this dependency report on a Word document, print it out, attach it to your runbook so that anybody on your DBA team can have a look at the dependency report to assist them in understanding how this whole thing works. Now that's done. What we're going to do is we will failover. Now before I do the failover, remember the temp DB is stored in my local drive, which means on WS Cluster 4 or on all of the nodes in my cluster, I need to make sure that that folder exists. I'm going to go back to WS Cluster 4. I'm going back to my temp DB drive. And again, this is a local drive. I'm going to create a folder named MSSQL. Grant the SQL Server Service account full control permissions on this particular folder. Again, add a SQL Server Service account. And grant it full control permissions. If I don't do that, failover will fail. I won't be able to move my SQL Server resource group from WS Cluster 3 to WS Cluster 4 because my temp DB database can't be created. Going back to the lesson on protecting your system databases, if you don't have the temp DB database, your SQL Server instance is down. So that's one thing to really keep in mind. I want to move this to node 4 or node 2, which is WS Cluster 4. Move that there. And looking at how the failover process works. The dependency defines how the failover process works. SQL Server agent goes offline first, and then the SQL Server service goes offline. Then all the other resources that don't have any dependencies. Look closely at the IP address. The 192.168.0.217 IP address goes online, and that's when the SQL 2012 Cluster 2 virtual computer name or the network resource name went online. So now, if I go back to my PowerShell script and rerun the exact same parameter or query earlier, I now have two IP addresses for my SQL Server virtual server name. These IP addresses pertain to the 192.168.0.217 and the 172.16.0.217 IP addresses. Earlier, this wasn't there because my add node process is not done yet and it wasn't able to register the new virtual IP address. Going back to my failover cluster manager, I can then go back and move this to WS Cluster 3. It's interesting watching how the resources are being turned offline or being brought offline and back online. It explains how the dependency report works. So in this demo, you've seen how I configured a Windows Server Failover cluster that spans multiple subnets, or commonly known as geographically dispersed clusters. You've seen me installed a SQL Server Failover Clustered instance on top of a geographically dispersed cluster. Tested failover and failback. I know we're not done yet here because there's still a lot of things that I need to configure. Like, for example, making sure that my preferred owners are properly set and that my priority is set to high. But I know that my failover and failback test works. Once this is configured, I can go back to Active Directory, look at the Active Directory objects. I want to open up Active Directory users and computers and check the servers if the virtual server name or the virtual computer object has been created in my Active Directory. So I now have SQL 2012 Clus 2. The Failover Cluster Virtual Network Name account has been created. And if I look at my DNS server, the DNS entries for both IP addresses are now configured. SQL 2012 Clus 2 has two entries, one for the 172.16.0.217 virtual IP address and the 192.168.0.217 IP address. This is how it affects your DNS and your Active Directory. So I strongly recommend that you take a look at the article that I wrote on mssqltips.com. It walks you through the exact same process that I did. The only difference is now I'm working with Windows Server 2012 for this demo, whereas the article walks you through the process of using Windows Server 2008 R2.